In this video presentation, we shall be once again focusing on the environmental issues that are related to products that are derived from the Haber process. Most specifically in this short video presentation, we shall be focusing on ammonium nitrate. Ammonium nitrate is derived from ammonia and it is used either as a fertilizer or as an explosive. Let's go to the METSEC assessment criteria, where I will focus particularly on what we shall be learning in this video presentation. Once again, we shall be focusing on METSEC assessment criteria 12.3F, where we shall be seeing a case video of ammonium nitrate. Ammonium nitrate, which is vastly used as both primarily a fertilizer, but also as an explosive. Now, in the video that you shall be seeing, which has also been introduced by my introductory video, so there is first my introductory video, and then on the final and fourth slide, there is the video proper. My introductory video is to explain the gist, the most important part of the video, so that you know what to look out for. But basically, the video deals with the misuse of ammonium nitrate, either ammonium nitrate that is accidentally misused by improper storage or by purposeful misuse, when it is unfortunately used as a weapon. Okay, weaponizing ammonium nitrate, unfortunately, is one of the major drawbacks of storing large amounts of ammonium nitrate. Okay, there is also this issue addressed in the video on the final slide. Let's now move on to my introductory video on the next slide. As you shall see in the video on the next slide, ammonium nitrate has its very big advantages because, after all, it is one of the most important artificial fertilizers, which is used in order to sustain the world's population at its current level. Currently, the world population is around 7 billion, and almost half of that population would not be able to survive were it not for artificial fertilizers for food production. However, it comes at a very serious environmental cost. Now, there are environmental costs that are related to excessive use of fertilizers, and ammonium nitrate is one of those fertilizers. But then there is another serious problem associated with ammonium nitrate. It could be stored for use as a fertilizer, but it could be stored improperly. In such situations, ammonium nitrate could quickly become an explosive substance. The video that you are about to watch explains how this can happen, and it refers to several scenarios where ammonium nitrate was either intentionally used as an explosive, such as in the Oklahoma bombing, which you shall see some video footage of, but also accidentally. Let's say it is accidental, because after all it was stored in a warehouse in Beirut 2 years ago. There was a vast amount of ammonium nitrate. I believe it was millions of pounds of ammonium nitrate, several million kilos of ammonium nitrate. They had been improperly stored because they had been stored for a very long time, 7 years, in wet, moist conditions. And as the narrators, there are two narrators. There's the principal narrator and there is a chemist narrator who goes into the nitty-gritty of the chemistry of why ammonium nitrate can be unsafe in certain circumstances. But basically what they both say is this, that if ammonium nitrate is stored in very large amounts all in one place, in moist conditions, so it has to be a moist environment, it quickly becomes like a hard cement. So that if there is a heat source or a fire very close by, this above 200 Celsius will start to initiate the decomposition of ammonium nitrate. And when ammonium nitrate decomposes, it decomposes very fast into nitrous oxide, water vapor, and nitrogen. So if you've got this cement-like mass with gases building inside, it's like a time bomb. Because once the pressure inside is raised to a critical level, then there is the chance of what is called a supersonic blast, where the pressure buildup literally blows the hardened mass of ammonium nitrate, and there is a supersonic shock wave generated that travels for far distances. It could travel for over a kilometer in distance. The supersonic shock wave has a very high temperature at its crest, if you like, its front part, which could reach several thousand of degrees Celsius, and also the force itself, since it's traveling at such a high speed, can break anything that is brittle, including human bones. So this is a very serious environmental consideration. I mean, when you have a chemical that is being stored for use as a fertilizer, and that suddenly becomes a high explosive that could destroy whole neighborhoods, it could kill people, it could damage the environment besides the direct damage in terms of air pollution, okay, and also water pollution, because of the exploded particles and chemicals also enter the water system. Then of course it could create effects in that way. But the narrator then goes on to also explain that it is only in extreme circumstances really that ammonium nitrate explodes. She does emphasize the fact that in order for an explosion to take place, you need it to be stored in vast quantities all in one place. It must be improperly stored for a very long period of time, typically in moist conditions, and it must be directly next to a fire or to a heat source. So if any one of these three factors is not there, then ammonium nitrate really becomes a very, very safe chemical to deal with. And it can be used as a fertilizer if it is properly stored. However, as we shall see in another video, ammonium nitrate, even if properly stored, even if it does not explode, even if it is properly applied as a fertilizer, can lead to other serious environmental implications. It can lead to serious environmental damage in other ways. Okay, now go on to see the video and return to this video should you not understand anything that is said in the narration. Thank you.
In April 1995, a truck bomb ripped apart a building in downtown Oklahoma City. In August 2015, a series of explosions shook the port of Tianjin in northern China. And in August 2020, a warehouse fire set off a blast in Beirut so powerful that neighboring countries could feel it. These were all caused by the compound ammonium nitrate, which over the last century has been involved in at least 30 disasters and terrorist attacks. But what is ammonium nitrate? Well, it's used in all kinds of things, from making antibiotics to instant cold packs, and it's a key ingredient in fertilizer. You might be wondering, why are we using something that has the potential to be so deadly to grow food? I like to think of ammonium nitrate as a Jekyll and Hyde chemical. When it's stored properly, it's the mild-mannered Dr. Jekyll. Plants love it because it supplies them with nitrogen, which they need to grow. And although our atmosphere is mostly nitrogen, plants can't actually use it in that form, but they can use it in the form of nitrate. Under the wrong conditions, ammonium nitrate can turn into Dr. Jekyll's evil alter ego, Mr. Hyde. So what makes this normally harmless compound turn deadly? First, you need a lot of it. There's this thing called critical diameter, which is essentially the amount of a compound you would need for it to detonate. Ammonium nitrate's critical diameter is huge, about 100 times bigger than TNT's.
It's quite inert by itself, but sometimes if there's a fire quite near the ammonium nitrate, and ammonium nitrate is in a huge pile, ammonium nitrate can catch on fire.
Once ammonium nitrate reaches 210 degrees Celsius, it starts to melt, quickly producing a bunch of gases, mainly nitrous oxide, water vapor, and nitrogen gas. If those gases can't escape, temperatures go up, and the reaction gets faster and faster. Now, this on its own could lead to an explosion. In the case of Beirut, 6 million pounds of ammonium nitrate had been improperly stored in a warehouse, sitting around and soaking up moisture for nearly 7 years.
And particularly if ammonium nitrate has been a bit wet, it becomes very hard like cement. It's not fluffy powder anymore.
So add a fire, and that hardened ammonium nitrate starts to heat up and melt.
And then the pressure starts to increase where the gases can't escape.
The burn rate, or the speed at which ammonium nitrate is burning, starts to pick up. When the burn rate is slower than the speed of sound, that's deflagration. But when it becomes faster than the speed of sound, that causes a shockwave through the ammonium nitrate, which detonates it. But ammonium nitrate doesn't need to be in a compressed form to create a disaster. At the port of Tianjin, 1.7 million pounds of ammonium nitrate was being stored in a warehouse near a place where nitrocellulose was also being stored. Unlike ammonium nitrate, nitrocellulose is highly flammable. The nitrocellulose caught fire, spreading to the stored ammonium nitrate, causing it to detonate. Tianjin and Beirut were some of the deadliest accidental ammonium nitrate disasters over the last century, but terrorists have also weaponized the chemical, like in the 1995 Oklahoma City bombing, where a terrorist detonated a truck loaded with 5,000 pounds of ammonium nitrate fertilizer, killing 168 people. When I see a large explosion on the news, my first instinct is to ask, was that an accident or was it planned?
If it's a terrorist attack, you wouldn't have a fire. It will happen very quickly. You wouldn't have time for people to video it. It'll be done within minutes. Because what they're doing, they have an explosive, they will detonate it, cause a blast, do the utmost damage they can, and that's it.
Because of its prevalence in terrorist attacks, some countries have outlawed ammonium nitrate. In one instance in 2011, the US Army detonated about 2,000 pounds of ammonium nitrate fertilizer that it collected in Afghanistan. It was done very far away from homes or people, so the resulting shockwave wouldn't cause damage or injury. Sometimes, the shockwave is more deadly than the explosion itself.
A shockwave is compressing the air going through the atmosphere. And at the tip of the shockwave, the temperatures are 3,000 to 4,000 degrees centigrade. And the speed of the shockwave is supersonic. So as this shockwave is going through the atmosphere, as it hits windows, of course it shatters them because it pushes them out. As it hits people, it will break our bones because they're brittle, but the rest of it will go through, but it'll burn us because it's very hot. It will flip over cars, it will flip over ships. It will bring anything brittle, it will shatter anything brittle as it goes through the atmosphere.
So if you find yourself in a place where you see a massive fire burning, get as far away from it as possible and away from any windows because you don't know what's burning. So if it detonates, the shockwave that follows could be devastating. Yes, all of this is scary, but Dr. Akhavan made it clear that we should not be freaked out about ammonium nitrate.
Because people worry now, so they shouldn't be worried about ammonium nitrate. It's safe to use. There's nothing wrong. It's not classed as an explosive, so very rarely does it go up. It's only when it's old and there's a fire next door to it, and also it's stored in huge quantities. Otherwise, it's fine.
So having a bag of ammonium nitrate fertilizer in your garage is not cause for concern. So keep on using it. Your tomatoes will probably thank you. Happy gardening.